3.7 Lesson 2, Derivatives of Composite Functions, the Chain Rule. Our objectives for today are 1. You'll be able to find the derivative of a composition of 3 functions by using the chain rule. And 2. You'll be able to find the derivative of a composition of 4 functions by using the chain rule. For finding the derivative of a composition of 3 functions, we will use this vocabulary. We have our inside function, our middle function, and our outside function. In a composition of 3 functions, you have a first function, the function that goes to work first, and then the second function, which takes the output from the first function and does its job, and then the third function, which takes the output from the second function and then does its job. Whenever you have a composition of functions, to find the derivative, we would have to use the chain rule. The first skill that you need, just like you saw with Lesson 1, is to be able to identify the individual functions that are composed together to give you your composite function. So here we have y is equal to sine cubed of 5x. And there are different ways you can write this function. And another way you can write this function is you have sine of 5x, and that is being cubed. So perhaps when you write the function in this particular way, it is easier for you to identify the 3 functions that are the functions that are composed together to give you y. So the insidemost function, the first function that goes to work, is 5x. So you take an input, x, and multiply it by 5. The output would be 5 times the input. And the second function would be sine x. We take the sine of 5x. And the third function would be raising to the third power. Whatever the output from the sine function is, we'll cube it. So our individual functions are f, g, and h as follows. So the individual functions are, our first function is our inside function, and then we have our middle function, our second function, and we have our third function, which is our outside function. So we have f of g of h of x, and we can write it this way: f of g of h of x is 5x. And what is g of x? G of x is to take the sine, so we have f of sine of 5x. And what is f of x? To cube. So we have the cube of sine of 5x. So this is important for you to understand so that you can apply the chain rule correctly to find the derivative of this composition of 3 functions. Before we look at that, let's look at another example in which we will see how the individual functions are composed to give us our composite function of 3 functions. So the function for number 2 is y is equal to the square root of cosine of 7x. You can write it another way. You can write it as cosine of 7x raised to the 1/2 power. So you can now identify your functions. Your inside function is 7x. Your middle function is cosine, and your outside function is raising to the 1/2 power. So your individual functions are f, g, and h. Your inside function is h of x, which is 7x. Your middle function, or your second function, is the cosine function. And your outside function, or the third function in the composition, is the square root function, or raising to the 1/2 power. So when you compose these 3 functions, you get the function y. Y is equal to f of g of h of x, which you can write this way: f of g of h of x h of x is your inside function, the first function, it is 7x. G of x is your middle function, your second function, it is cosine, so now you will have cosine of the output from the first function, which is 7x. And then your outside function is the third function, it is the square root function, or raising to the 1/2 power. So you will take the output from the middle function, which is cosine of 7x, and then you're going to raise that to the 1/2 power. It is important for us to understand this so that we can appropriately apply the chain rule to find the derivatives of each of these two functions for numbers 1 and 2. So here we have the chain rule. This is what we learned about during lesson 1, the chain rule. So if you have a composition of two functions where the inside function is g of x and the outside function is f of x, the derivative of the function y would be y prime. You take the derivative of the outside function, evaluate it at the inside function, and then you multiply by the derivative of the inside function. And here we have the chain rule written in words. To differentiate a composite function, differentiate the outside function, which is f prime, with respect to the inside function. In other words, evaluate it at the inside function, and then multiply by the derivative of the inside function with respect to x. So let's see how we can apply the chain rule when you have a composition of not two functions, but three functions, as we see for number 1. So we have y is equal to sine cubed of 5x. We can go ahead and rewrite it in an equivalent form as sine of 5x to the third power. And again, how do you use the chain rule? You begin by taking the derivative of the outside function, evaluate it at the inside function. And if you look at what we did earlier, our third function, which is our outside function, is x cubed. So to find the derivative of y, you begin by finding the derivative of the outside function, which is 3x squared, but of course you have to evaluate it at the inside function of sine of 5x. So you get 3 sine of 5x squared. So this is this particular part of the chain rule. So what's the next part of the chain rule? You have to multiply by the derivative of the inside function, which for this problem would be sine of 5x. So now you have to multiply by the derivative with respect to x of sine of 5x. So sine of 5x is a composition of two functions. So how do you find the derivative of a composition of two functions? You have to use the chain rule again. Okay? So when you are finding the derivative of a composition of three functions, you are actually having to use the chain rule twice. Now we have to use the chain rule again to find the derivative of the inside function sine of 5x, because that is itself a composition of two functions. So you would go ahead and write y prime is equal to 3 times sine of 5x, that quantity sine of 5x squared, and then here, to find the derivative of sine of 5x, the inside function is 5x, and the outside function is sine x. So the chain rule says, find the derivative of the outside function. The derivative of sine is cosine, so I write cosine, and I have to evaluate that at the inside function of 5x. And then, using the chain rule again, I multiply by the derivative with respect to x of the inside function 5x, which is, of course, 5. So my final answer would be, so I have this 3 here. I know this derivative of 5x is 5. 5 times 3 is 15, so I write 15 sine squared 5x times cosine of 5x. And that's my final answer for this problem. So here we have number 2. and our function is y is equal to the square root of cosine of 7x, which we can also write as cosine of 7x raised to the 1/2 power. And to find the derivative of this composition of three functions, we will use the chain rule. The outside function in our composition of three functions is the square root function, x to the 1/2. So we need to begin by finding the derivative of the outside function evaluated at the inside function of cosine of 7x, which itself is a composition of two functions. So now we find the derivative of the outside function evaluated at the inside function, so y prime, and we have x to the 1/2, which is a power function, so we use the power rule, bring the exponent to the front, and then normally you would write x here, but we are evaluating the derivative of the outside function at the inside function of cosine of 7x. And you would subtract 1 from the exponent of 1/2. 1/2 minus 1 is negative 1/2. And then the chain rule says, after you've done that, what do? You multiply by the derivative with respect to x of the inside function. So now we have the derivative with respect to x of cosine of 7x, which is a composition of two functions. So you have to find this derivative by using the chain rule again. So whenever you have a composition of three functions, you have to apply the chain rule twice to find the derivative. So now we have y prime is equal to 1/2 times cosine of 7x to the negative 1/2. And the derivative here can be found by identifying that the inside function is 7x and the outside function is cosine. So the derivative of the outside function is negative sine, so we have negative sine evaluated at the inside function of 7x, and then using the chain rule I multiply by the derivative with respect to x of the inside function 7x, and that derivative is, of course, 7. So I have 7 times 1/2, which would be 7 over 2. And then I have cosine of 7x to the negative 1/2 power. Again, as we saw during lesson 1, whenever you have a negative exponent in the numerator, you can take the power to the denominator and the exponent will become positive. So we can simplify by taking that power to the denominator, and I will have cosine of 7x to the 1/2 power. Of course, raising to the 1/2 power is the same as taking the square root, so you could also write that as the square root of cosine of 7x, and that would be in the denominator. So now don't forget about the negative sine of 7x. So negative 1 times sine of 7x. So you have sine of 7x, and then you have negative 1. So when you multiply the negative 1 to the 7 in the numerator, you get negative 7. So this is the final answer that we have for number 2. So we just looked at objective 1. You'll be able to find the derivative of a composition of three functions by using the chain rule. And now we'd like to take a look at what a problem might look like where you have a composition of four functions. As we saw with objective 1, when you had a composition of three functions, you had to use the chain rule twice. So when you have a composition of four functions, you would have to use the chain rule 3 times. So you'll be able to find the derivative of a composition of four functions by using the chain rule. So let's take a look at a composition of four functions. So here's number 22, which is a problem from your homework for tonight. I'd like to just get started with this problem by identifying the four functions that are composed together to give us y for number 22. And then you can apply the chain rule, as we said a minute ago. You'd have to apply the chain rule 3 times to find the derivative of the composition of these four functions. First of all, you want to understand that the first function is 5x plus 3. The second function is raising to the 4th power. And then you're taking cosine of 5x plus 3 to the 4th power. And then finally, you're raising to the 5th power. So the outside function is x to the 5th. So we're going to write f of x is equal to x to the 5th. That's our outside function. And then we have g of x, h of x, and maybe I'll write k of x. So the first function is k of x, the second function is h of x, the third function is g of x, and the outside function, or the fourth function, the last function, is raising to the 5th power. And again, the insidemost function is 5x plus 3. And then what are we doing to 5x plus 3? We're raising it to the 4th power. So our second function would be x to the 4th. And what are we doing after that? We're taking cosine. So our third function would be cosine of x. And finally, the last thing that we do is we take the output from the cosine function and we raise that to the 5th power. So the fourth function is raising to the 5th power x to the 5th. And you can see how we have a composition of these four functions. Y is equal to f of g of h of k of x. So we have y is equal to f of g of h of k of x. So we have y is equal to f of g of h of k of x is 5x plus 3 and then we have y is equal to f of g of h of x is raising to the 4th power. So now we're going to take the output from our first function, which is the input for the first function is x. And what does the first function do with the input? It multiplies by 5 and adds 3. So the output from the first function is 5x plus 3. The second function will take the output from the first function and raise it to the 4th power. So now we have g of 5x plus 3 to the 4th power. So now what does the third function do? It takes the output from the second function, which is 5x plus 3 to the 4th power, and it takes the cosine of that. So we have f of g is the cosine function, so we have cosine of 5x plus 3 to the 4th power. And then finally, what does the last function do? The last function is the outside function. It takes the output from the third function and it raises it to the 5th power. And when we do that, we get what we have for number 22. One thing that students may make a mistake is they might do the following. This is not correct. Some students might say that here you have the power of a power, so you can just multiply the exponents. But you can't do that, and the reason for that is because this exponent of 4 is applying only to the 5x plus 3. It is not applying to cosine of 5x plus 3. It is different from having it that way. students who would try to multiply the exponents 4 and 5, they're actually thinking of the function for number 22 in this way, but it's not equivalent to what's given. They're thinking of it in this way. But that's not what we have. Writing it this way is different from what we have for number 22. This is not the same as number 22. And the reason why it's not the same is because in number 22, the exponent of 4 that's in green is applying just to the 5x plus 3. But when you write it this way, the exponent of 4 is actually applying to cosine of 5x plus 3. And because in this situation you could multiply the exponents of 4 and 5, because the exponent 4 here is applying to cosine of 5x plus 3, but you can't do that for number 22 because that's not what you have. Again, this is not what we have. It's not what we have for number 22. But if you had this problem, then you could multiply the exponents and you would actually have just a composition of 3 functions rather than a composition of 4 functions. But for number 22, it is not correct to multiply the exponents 4 and 5 because number 22 is not what I wrote at the bottom here. So I will just get you started with number 22. So you begin by finding the derivative of number 22 by taking the derivative of the 4th function, the outsidemost function, which is, of course, x to the 5th. So to find the derivative of that, you would use the power rule. So you would have 5 times, and you will evaluate this derivative at the inside function of cosine of 5x plus 3 to the 4th. And then you have to subtract 1 from this exponent of 5. 5 minus 1 is 4. So you're going to write 4 here. And then what do you have to do? You have to multiply by the derivative with respect to x of this inside function. Cosine of 5x plus 3 to the 4th. And when you look at that, you have a composition of 3 functions. You have a composition of 3 functions where the outsidemost function is actually cosine. And the middle function is x to the 4th. And the insidemost function is 5x plus 3. So now you have to do that like we saw number 1 and number 2. So you will have to apply the chain rule 2 more times to complete the problem. And this particular part in red would be like what you saw for numbers 1 and 2. Because you have a composition of 3 functions, so what would you do next? You would find the derivative of the outsidemost function, which is cosine. The derivative of cosine would be negative sine, and you would evaluate that at the inside function of 5x plus 3 to the 4th, and then you would have to multiply by the derivative with respect to x of that inside function, for which you would have to use the chain rule again, because that itself is a composition of 2 functions. You should now complete the problem for number 22 as a part of your homework for tonight. So in number 22, you looked at finding the derivative of a composition of 4 functions by using the chain rule. And critical for you to be able to do these problems correctly is just to understand the order in which the functions are composed together.